Right, so everyone, welcome. How we doing? Right, let's get that all set up. Ah, yeah, we're doing a Windows port today of the code we wrote on the Linuxes. Get everything set up. Okay, so I need to go into the workbench, game van engine, and boot up the solution. Hey there, Rohan, how you doing? Good to see you. Good to see you. Yeah. Right, so where are we going? I need to find my stream on my phone so I can get the chat up. Uh, right. So, yeah, today's my first day back after a 2 week break. Um, so I might be slightly rusty, but I'm pretty sure I remember where we were at. So, the first week we spent getting the GPU stuff done, and then we've been spending the past few, like, how many weeks? 2 or 3 weeks, getting, well, it's been longer than that. Well, I'm thinking in terms of like days that I've programmed in, but anyway, working on basically the core engine. So we've done a lot of the core engine work on the on a different platform, and so we've done the keyboard input, mouse input. Yeah, keyboard, mouse, gamepad, touchpad. We didn't do accelerometer and gyroscope, although we know kind of how to do those. We've done a lot of research into it. We're going to be porting this to Windows today, hence why we're on Windows. So I don't usually develop on Windows, but we've got a lot of code that doesn't build. So we're just going to go ahead and get it building. We've also got like a system for logging as well, like a logging system. So we should really be porting that over as well, because that's going to give us some errors. But yes, that's what we're doing today. I'm having an omelette. Excellent. What sort of omelette you got? Love me a good omelette or scrambled egg. Chat only. There we go. Right, I got the chat on my phone now. So what's really great is I don't know too. So I've done some research into Windows. I haven't done. I'm not super familiar with it. Um, so I've not really done any Win32 support for gamepads yet, but I've been given some files by someone in the Discord. So we're going to be looking at how they've done it basically. I know there's like basically three different APIs. There's like raw input, direct input, and some HID interface one. But yeah, we're going to be taking a look at this when we try and port our OS code over to Windows. So the thing is we've changed the OS layer API, meaning that if we try and build anything right now, it's just going to break. So the best thing to do is just get some stub code in and just get this thing building again. And all it'll mean is the input stuff won't work, but the rest of it will still work. So that'd be a good place to start. Then we can plug in the input, the logging interface. So we can actually log out stuff to files, because we can do that on other platforms, but not on Windows right now. So that'd be a good idea. And also figure out how to do that, because we've got like a GUI application and it doesn't really have a console allocated. So we're just going to probably put that to files for now. I'm not sure if I necessarily care about printf anymore. But yeah. So this is really tiny text for some people, I imagine. But yeah, so we've got like a window, we've got like an OS header where there's like an OS interface that we implement. So with this, is it mostly implemented by OS Linux here. So we've got one for Windows as well, and this one is just really old and got basically nothing in it. It's got like 400 lines of code. Like we can open up a window basically and that's it. and we're not really parsing too many events. Okay. I love seeing something like this to add some jazz there. Yeah, that's it. I think that's when we did that logging system last time, we based it off of RxI's log.c. Well, not really based it. We looked at it for inspiration, and said, like, this is dead simple. We want to do something dead simple like this. And what we landed on was something completely different, but it was just, let's be inspired by something simple. So we've still got obviously the standard log level stuff that people typically do, right? I think this is very much like what RxI's log.c is like, right? Where it does this basically. Um, but we basically have like a tag, um, and so this is like a category or whatever. So you basically each one of these tags gets its own file, and we can just the idea is, so there's a file purely for stack traces when it crashes. There's a file for OS input if we want to log that, and there's a whole file for graphics shaders to log out to. But there'll be tons more, obviously. But yeah, we've sort of just rolled with this sort of thing. So we'll be adding more, and we're able to check if some are enabled, and that would be pretty nice. But yeah, people really overcomplicate these systems, and it's just nice just to be able to make something simple. So ours just goes out to a file. I want to find a way that we can view the file live. I think we can just use tail. So if I just open up the Windows subsystem for Linux, we'll just use tail-f to view the log files, I guess. The approach we might take. Yeah. Right. So let's go ahead and implement all the stub code. So basically, a lot of this stuff isn't going to be implemented. So we go to the OS Linux, and what we want to do is find we probably just want to open up OS Windows and just go down from the top to bottom and just see if there's any missing things. So really, it's kind of all out of order, in a different order. So we should really correct that as well. So I don't think we have an OS make directory. We definitely have a file read all, I think. So don't have a make direct. Oh, we do have a make directory and a read all. Excellent. So we're going to bring this up to the top. This is in OS Windows, and we're just going to go ahead and put a section in there for it. Right, so let's just get this here. This just matches to what the os.h header is like. Don't know if I should zoom. I might zoom in for you guys. It might be a bit easier. Right, so then we've got this virtual mouse. So what virtual mouse means, it's like the operating system mouse cursor that you're moving around. And a mouse or a keyboard is simply the raw mouse or keyboard input. So and obviously virtual keyboard is the one that the OS uses basically, or the OS one gives you. Yeah, we basically want like a virtual mouse section, way to hide and show the cursor. Maybe this is a bit too big. I'm moving that down. So we just want to gut the implementation here because on Windows it'll just be different. So I think we'll do a find and replace for Linux to Windows in a sec. So we'll keep all of this here, and we'll implement this as we go. But we'll just have an empty stub code for now, and we won't do anything. Right, what is next after the there's window? Did we do a window? It's so warm right now, and I want to put my headphones on and listen to this lovely music, but there we go. Right, window size needs to go now because I think I moved that up a layer. So basically there's like os.c, and this is like So we have our OS abstraction, and there's some like there's sometimes shared data that just gets set by the backend, and when we have part of the interface that just simply returns that data in those structures, we simply just put it in this shared.c file, so we don't duplicate it in the Windows and the Linux backends. So an example is window bottom left, right? So that's window position. We just return an internal bit of information. So that is updated by os windows.c typically, and then we just simply have a function to return it. Oh, thank you so much for the sub with Prime. Thank you so much, Be Rousing. Appreciate it. S32 times 2 sounds cursed. What do you mean by cursed? There's two S32s. What's, I guess times 4 is better. You got 4 S32s. But yeah, appreciate the sub. You can go ahead and get access to the code if you want and browse this on your local machine. If you simply just do this. If you just join the Discord and see the instructions there, you'll be able to download the code and take a look. Right. This Windows backend thing. We're gonna make a new section. For window. Oh man. Gonna move that up a bit. Right, what's the next section? DLL. Do we have DLL open in? We must do. Yeah. Because when we did the Vulkan layer, right, we needed to load the Vulkan DLL. So we needed that. So what is next in Linux? So we've got to do virtual memory. We've already got that in there as well. Let's go and grab that virtual memory stuff. Virtual memory. I'm just trying to keep the files in the same order, you see. And yeah. Just make it a bit tidier. Right, it's looking good to me. Next section after the virtual memories is the OS. So there's a new pre-initialize, which simply just sets the page size, because when we in our main function, right, the first thing we want to do is like pre-initialize things so we can then set up our allocators basically with the virtual memory stuff. Yeah, we want to avoid calling this function every time, basically, so we just cache it. That sort of thing. So we need an OS section. Where's the Windows one? So OS, that's got OS initialize, but we also want to pre-initialize. And it's not really OS in its OS backend initialize, because there's actually an OS in it in the upper layer, which calls into this. So this page size thing here, we need to nick that, drop it in here. So it's no longer GOS Windows, it's kind of shared. So we've got to do a little bit find and replace for all of that. Drop that in there like that, and voila, fixed it all. There we go. Okay. We've still got a few more things to reorder, but I think it's just internal functions now. Have a look. Then after that, we've got to fix up some of this stuff, because by the looks of it, this OS Windows global used to just be, or it's a global right now, but really it should be, we put it inside the GOS structure in one of these sort of this backend data which gets casted into that OS Windows data structure. And the reason why we did it this way is so Well, yeah, mainly because it's consistent with the way everything else works, basically. Like all the other things, like OS input device, they all have this sort of like back-end data that's stored here, like next to the other stuff in memory, you know? But yeah. Right. So what we need to do is figure out what OS Linux does. So OS Linux, I mean, what is all this? Backend initialize, right? So this initializes all the X11E stuff. Backend poll events, we need one of those guys. Have we got poll events? Is this new? That is new. All right, this is a new thing. So this just essentially like checks if there's been any devices plugged in, unplugged, if there's any key presses, and it fills in an array of events, like an event queue, and then the upper layer is going to search for that. Then the upper layer can essentially like, so here when we do this iterate events, essentially if we've reached the end of the queue, we clear it, and then we just set the cursor back to the beginning, and then we poll like any more events, and then we simply just return the first one in the queue, right? And we keep returning the next one and the next one. So we need to have a function that simply populates those events in that array. Ooh. So what is next to do after the poll events? This is in the right. There's just an internal section. I think I got quite lazy with the sections after a while. It's just internal. There's like an internal header here that just has a bunch of internal functions that I've just dumped in and arrays and things like this. We're going to be doing the same thing on Windows as well. Okay. Rightio, so I think we've caught up there. So I think we got rid of the window open because we was like, you know what, we're just going to have one window. So I don't think we need this anymore. This can just go like when you initialize the system or something. We're going to take a look at that. Right, there's this thing here as well. Okay, so what we're going to do is we're just going to start with the data structures now. Get that sorted out. And then we'll move back into here and implement some of the stuff. Fine over here now. Been charged. Rightio. So how does this compare to the other OS ones, right? So we've kind of just included some stuff here. Goes OS Linux window, OS window. So this is OS window, Windows window. Let's do that. OS Windows window, my favorite. So then we want some form of static assert here. So this is just like saying make sure that the size and align. Wait a minute, are we missing things? I thought we needed good alignment, you know? Okay. Right, I thought I did something better. Yeah, we need to check the align is equal to that as well. Alright. So we've got some static asserts there, which is nice. You can use window IO completion ports to implement high throughput game server. What is that? Win32. Was it an IO? Not heard of this before. Yeah, I think like eventually I want to have the game networked in some way, because I think I want to have like a couch co-op game, but obviously have network capabilities, right? But yeah, I don't know if I'm not sure if we ever need. Hmm. All use the read file and write file stuff. How great! For processing multiple asynchronous IO requests on the multiprocessor system. The system creates an associated queue for the object. The sole purpose is to service those requests. Hmm. Yeah, I'm not sure how this fits in though. But yeah, it's just a queuing system, isn't it? For uh, hmm. Yeah, for doing I/O basically, like networking or file I/O, right? Um. Yeah, I want to try and disable rounded corners, but that didn't work out. I was like, these rounded corners suck. Um. Right. So on the Linux side of things, I think I do want to quickly throw those in as well, because that's a bit silly that we missed those, you know? On the Linux side, we've got a few of these here as well, which is like, ugh. Right, so a line of get these super lovely static asserts in, you know? So need them here for the input device. We'll be getting those for the window one as well. Can't believe I missed this. And voila. We did it. So, yeah, it's an event queue. You can put any asynchronous operation waiting to be picked up by the Win32 system. Hmm. Yeah, I don't think mine needs to be thread safe particularly. Yeah, I think it's just the main thread that's going to pick up that event queue. Yeah, I've not really thought about the threading story yet for this game. After we've done prototyping, though, for definite, we're going to look into that. Depending on what the game is. Like, because there's some really like fun stuff you can do, right? But it also could be a pain for dealing with bugs when it's the buggy system, right? So yeah, right. So the idea is we have a back end window which holds the back end stuff. Size doesn't belong there anymore, buddy. So we need to also put in. Right. We've got the size and align, been checked. Nice. We now need an OS input device backend thingy, right? Grab the Linux one, drop this in here. So this is our input device. An input device can be a mouse, touchpad, keyboard, gamepad, accelerometer, gyroscope, and it could be all of those or any of them, any combination of those. So it gets a bit fat, but oh well. So the idea is we're going to take this one, Linux, replace with Windows, and there we go. Delete all of this. We'll keep in a U32 placeholder for now because you can't have empty structures in C for some reason, but that's fine. So that's all good to me. The next one is we need this sort of thing here. Same replace, find and replace again. Cool. There's no GOS Windows anymore, right? Because that's stored in a different global instead. And now, yeah, we're gonna need to have more internal functions here in a bit. Hey, not so red. How you doing? Doing good. Doing good. Yeah, just been looking after the baby and figuring the baby out, but he's all good. He's doing great. Yeah, I'd taken a couple of weeks off, but now I'm back. So yeah, it's gonna be good. And we're starting on Windows, which is a shame. Does X11.h works on Wayland? Um, I think it does using X Wayland, but I think people say there's a bit of a performance impact or something, and maybe not all things work. I don't know. But yeah, it's in future, by the time this game releases, we might do a Wayland, might port it to Wayland, um, and just use that one. Reason being is because on the um, on the Linux operating systems, things typically move fast, and everyone just switches over to the thing, right? Um, but or we could do both, right? We could have two backends, probably, or two. We can check if they're running on Wayland and just do it. Because actually, we don't use too much of X11 anyway, so I don't think it's too difficult just to have Wayland running side by side. But it still just adds code, right? And I just did X11 because that's the thing I've used before, and I didn't want to learn too much because I already was learning to do the gamepad stuff from scratch, and that was a pain. Um, you don't have to design threads. Look at Redis. It's a single core in-memory store, but it enables single core parallelism by epoll. I don't know what this stuff is. Like, it's Redis thing. Or Redis, what is it? Redis, uh, alright, it's like a database thing. I'm not sure how this is useful. Like a server. In memory database. Pretty decent. Probably pretty quick then. Not bad. BSD license as well, nice. ANSI C. Very cool. Take a look at it. Yeah, I don't really use databases much. How's it like being a dad? Um, yeah, it's yeah, I don't know. Like, I know it's pretty fun, like seeing the baby, like, um, you um, yeah, I don't know. I don't know how to describe it in words. But yeah, it's cool. Like he's just so sort of like funny to just sort of like just look at him and he's cute and yeah, he's just quite funny. I don't know what else to say. Um, but yeah, he's still very young as well. Like right now, his he just sort of like he's usually like pretty chill when he's just sort of sleeping or just looking at you and just. But then like when he wants something, is instantly just like gonna cry his eyes out, and then you just get him his thing, and then it's just chill again. So yeah, he makes all these these cute little noises. But yeah, it is you know, it's interesting that you have to sort of like they're in this state where they need your full attention. And they're pretty much helpless without you, you know. So yeah, they're good fun. Um, yeah, it's it's difficult to describe, I guess. Um, yeah, he's grown quick. Um, do. He's also keeping me up at night, you know, a little bit. Like we're quite tired most days. So it's hard to be there based on your description. Nah, it's hmm, it's not difficult. It's just well, yeah, actually no. It's difficult initially. So when we first staying in the hospital, and I stayed over the first night when the baby was born, and the second night. And the first night he was chill. Like we would just he'd sleep the whole night, and it was awesome. The second night, however, he just he was hungry, but we just couldn't quite like he couldn't quite breastfeed properly yet. And it was just trying to get him to learn being a human being, you know, and eat. Um, yeah, he was so he was crying a lot, and it was very difficult, and it just made me think like, you know, it's really great that me and my wife are there looking after the baby because I wouldn't know how like a single parent can, you know, raise a child. It must be difficult, you know. So I guess it becomes easier over time. Yeah, it's definitely quite. It's definitely a lot easier now. But still, though, when you sort of got to like change him and get some things, you got to put him over your shoulder, and you got to try and like do things with the other arm. And yeah, yeah. I don't know. Yeah, yeah. It's hard to know what the baby wants because it's only got one way of telling you like what he wants. But it's only like one of five things at most, right? Changing, feeding, um, yeah, changing, feeding. Maybe he's a bit frustrated, um, and yeah, like you just check those things out. Or sometimes he's trying to actually just go to the toilet. That's another one, and you just have to sort of like just wait it out. Um, yep, yeah, it's cool though. So proper cute as well. The hardest thing was trying to figure out like, right, we got this. We have to go out now, and then you realize that you've not prepared everything. You have to get back together, get it all ready, and it's getting used to that. Um, and it feels really scary because you know how delicate he is, and you're like, okay, I got him in this pram. Is he comfortable? Is he warm enough? Um, you know, if he, you know, where can I go and change him and all this, and just get used to all that, you know. Yeah, it's cool. Um, yeah, it's much better now. I've had him back for a few days, and I'm so glad that I got this time off work. So I got like three more weeks left, so I can just sit and learn, figure this guy out. Thank you, not so red. Yeah, it's gonna be cool. It's gonna be great. Yeah. So yeah, just take it as it comes, and I'm sure I'm gonna be decent at it. Yeah, thank you. Yeah, how's things been with you? You been up to much? You enjoying the break, school break? Um, right. So I think we've got the data sorted out now. I think this is wrong though, and this page size is wrong, and so is that one. Yeah, that one stays there. Right. So right. So we need a couple of back end functions. I think we need like one of these sort of guys and these sort of guys, but for Windows. And this basically just returns the Windows specific data for the operating system layer, the Windows specific data for the operating system window. Basically, Windows window, good old Windows window. So yeah, this gives us the H instance. This one gives us the HWND, which is the window handle. So yeah, we're just gonna be sorting out. So we've got to implement these guys. So let's go to the Linux ones and grab those. So segfault handler, let's drop them here. Window. I'm enjoying it, but I don't know about my family. I hear got to get. Oh, I got to get a job a lot. Yeah. Yep. Yeah, I know, right? And your parents are probably just like, when I was your age, I had this job. When I was your age, that sort of thing. Yeah. I remember those days. But yeah, just see if you can get something programming related. Or maybe not. Maybe get something that's you can do part time and you can sort of work your way into getting the programming job that you want, right? Because maybe you don't want to sit at a computer all day and then sit at a computer even more. Maybe it might be better just to be a you know work in a shop or something, until you work all that out. Um, Helps with the RSI that way, so you're not overworking yourself. Baby proofing the house's biggest challenge. Yeah, that's something that we've got to do soon, and sort of think in terms of like a habit, because the biggest thing is right now he cannot go and do things, but soon he will be able to do things. And yeah. Oh shoot, I've been doing all this renaming. Oh no, it's fine. It's just been Linux. It's fine. But yeah, sooner or later it's going to be walking. Like, give it 6 months. So we've got to kind of build up the habit soon, and just think about leaving scissors around or something like that. Um, just put stuff away. Okay. The crap is this thing still doing here? Hmm. This is kind of shared, right? Why isn't that shared? Right, we're going to take this then, and we're going to move that into os.c. There's a virtual memory section. Oh, come on. Oh, you know what? I can't be bothered. Let's just leave it there. Right, so what else are we missing? Pre-init. Right, poll events has got to get populated. So OS open window. Where do we do that in Linux? Now, I think we did that when we just open up when we just initialize the backend, right? Backend initialize. Right, Linux open window. Okay. So the backend says Linux open window width height. Okay, so we'll do a similar sort of thing on Windows. Do that, right? So Windows window open, and we'll put that underneath. So in here, we're going to take this guy. It's got to change it a bit. We'll put it at the bottom here. There's a message box there. Why is that there? About that. It's under the get last error here. So this returns void. And U32, U32, fantastic. Windows window open. And this just gets called at the bottom of OS backend initialize. Because we only really have one window that we care about, I think, for this game. Multi-window, probably not. So we just do 800 by 600 right now. Yes, we haven't sorted that out. That'll do. Right, so what's the next sort of thing? So there's all this GOS Windows and all of that. So I think in the Linux side of things, at the top we typically do this like OS backend thing. Equal OS Linux. Is that right? Do we say OS Linux? Okay. Right. So what we want to do is essentially drop these in places. And that's going to get it from the global, like essentially it's doing like a cast. It's just going into the GOS backend data, casting that into the Windows backend specific data. That's all it's doing. And basically we want to be changing any of this to OS backend, something like that, right? So, and then we just want to fix up all of those with this. So we just drop that in there like that. Keep going. This one here, same thing. I doubt any of those will be needed. We'll have a look. Window is fine. Alright, full circle, we're good. Okay, so fix that problem now. Anything else that we're missing from this stub code? I guess we can start trying to compile it now. I think there's going to be a problem with the static sizing, but let's just let the compiler tell us the problems now. And I think we're in a good place. Yeah, I'll think about it. Alright, so we've got on support platform here. So here we haven't actually implemented the sizes at all. So I was saying that the sizes are going to be wrong for these backend things, but they're actually not implemented yet. So we need to say else elif defined core OS Windows. That's something that we define. We just, it's kind of like underscore win32, but we just make a nicer one. The downside to doing this is you have to include core.h in the file, and if you don't, it simply won't work. Right, this won't happen, but pros and cons, right? But yeah. So how big is the window backend? So we go into the OS window internal. We could take a look at it. This is 8, because you see it's a pointer. There's just 8. So 8. Well, obviously this gets really hard when it starts getting a big structure. You can kind of change the static asserts to be greater than or equal to kind of get by if you're in like a debugging mode, but yeah, anyway. The backend size is h instance, which is another pointer, so it's 8 for now. And the input one is basically just 4, because we haven't put anything in there. We've just put a placeholder integer 32, and we'll sort that out in a bit. So now let's hit compile, see how well we do. So nothing called window ID anymore, that is correct. We've got this window backend function, which, yeah, it does exist. It is called inside the GPU backend for Vulkan, I think. Where is it? Come on. Why don't I see it? Is it in open files or something? Current directory. No. Current project, please. There we go. So as you see in the GPU backend, we simply get this backend data, and if we're on Linux, we do this x11 cast into the appropriate ones, right? If we're on Windows, again, we cast into the appropriate ones in the window code to get the surface that we render to. Yeah, that's the reason why we have this thing. Just going to put void in there, and that should fix it all up. Like that. Next one. OS backend Windows. So it's no longer there anymore. Instead, there is a Windows. Wait a minute. Windows window. So again, it just casts the window, but we only have one of them, and that's an address of OS backend. Wait. GOS.window. I think so. Yeah. This one. Oh, okay, there's only one window, so it just does it anyway for us. Alright. Alright. So we'll call this one like OS window backend. Is that how we called it in the past? Window backend, that's all we've called it. So Windows window. And that would just be here like so. It gets the window handle for that. I think the music has stopped. Cool. So apparently got conflicting types. So this should return a pointer to an OS event. No. This one needs to go, but we're not going to delete it yet, and the reason is because we're going to need it. We're going to need some of this code here. I think I have in some of the example code we're going to be looking at, but I just want to keep it around just for now, so we'll comment that out. This is a global that should go. This stay here. Do that compiling. So really, we're just going to comment out all the code. Here, and just do the default response here, which is what you have to do typically in this event handler callback thing. Right, so apparently we're getting nearly there. I don't know. So we've got this ID thing. We should probably just delete this. Return ID, no more. Window size, I think we set that still. Check the OS Linux side of things, please. So when you open up a window in OS Linux, do you set the size? I think you do, right? Let's do. Oh, it's called dims now. Gotcha. S32, S32 now. There you go. Cool. Right, so there's this. Okay. Windows window and Windows window. Window backend. So this would be Windows backend handle basically. Voila. There you go. And got a couple more left. And we should have an empty... We should have it back up and running again, perhaps. GOS dot window dims. Alright, so it's booting up, and what do we get? Document cannot be opened, renamed, or removed. What? What? Oh, and then it runs. I feel like it's crashing in some way. So what I think we should do, we'll get to that in a bit. We should probably delete the build. Right, delete the Windowsy bits. And I think we want to try and build that again, just in case. I don't know what's going on there. I felt like there was something wrong. Right, so I made them back again. Where is this coming from? Can I... See, and I love how in Windows it's like, hey, I want to highlight this text, and I cannot copy it. The document cannot be opened. It has been renamed or removed. Like, where's that coming from? Hey, the name me Imagine. How you doing? No, we're on Windows, my friend. Windows. We're now Windows devs. Document. What was it again? Alright, we're running that again. Yep. Well, we're doing that lovely Windows port. So we're just sorting out the just getting a shim, well, an empty implementation for a lot of the stuff in, so we can at least boot the game back up. On Windows, that is me the first step, and then we'll probably commit that, give it a nice commit, and we'll progressively add features. We need to add the logging support. I don't know if it's trying to do that now. Not gonna lie, I don't know what it's doing. You know, that's probably what it's doing, isn't it? We should boot it up in main and just follow it. I feel like cannot be opened. It has been renamed or removed. It has been yeah, what is this, man? It's not telling me the document. So I feel like it's crashing somewhere, but it can't tell me the thing it's trying to open. Whatever. Hit pause. So it's running, right? I'm just jumping up the stack, get to my code. But it still runs. Doing fine. But now it's not. Oh, it's running. Something fishy is going on. I don't know. Let's not do the render frame stuff anymore, but it wasn't allowing me to pop the thing back up. Uh, right, we still got the same thing. Now it's a white window. How bizarre. Oh, I know why. You know why? It's because we commented out this. We're not polling the events anymore. Wait. We're not. I think it's because we're not polling the events. So I think the Windows system is maybe seeing this as like the application not responding. I think this might be it. So I think we'll plug a basic implementation of this back in, and then I think that will fix the problem we're looking at. Hey, they're not so red. No worries, no worries. I started working on a compiler this week. Nice. I'm almost done with the AST parsing and stuff, but I don't know what to do next. Do you have any good resources on type checking and semantic analysis? I know. Have you? Right. Um. So it really depends on the language, right? Um. If your language, yeah. So I guess that crafting interpreters book doesn't cover it because that's more of a dynamic language, isn't it? But essentially, you have your AST, right? And say if you have an AST, you basically want to go over all of your yeah, I don't know if I have any good resources for it really. Um, but you have your AST, and the basic idea is you need to resolve any um like that's not type checked, right? You need to go over you need to traverse the AST again, and you need to basically, if a type hasn't been resolved, you need to resolve it. Or if you have a reference to like you try and call a function, because I assume something you're writing is all out of order. You need to resolve um those identifiers into the actual a reference to the actual function, or the you know or the identifier. You need to resolve that to the actual type. So all you need to do is just traverse the AST and modify it to be to have the correct types, and you just probably want to do a recursive descent and then go all the way down to the lowest node that you can and replace that identifier with like the actual an AST node which references a function instead, or a actual type, and then you can put the types in the expression nodes, if you get what I mean. If that made any sense. Um, but yeah, I don't really have any specific resources that I can remember. But yeah, definitely check out the one that Rohan put in. He's a compiler person too. Yeah, all you're doing is just checking the tree out. And if you have any out of order, the biggest problem is if you have any out of order, like say if like in C, if I parse this, I know everything above is defined, fully defined. But in something that you're probably writing, you're probably not inheriting this legacy thing. So the idea is when you have it in a syntax tree and you've just got like identifiers, that one might not be ready yet. So how do you solve that? Well, you could solve that problem by basically trying to do the type checking and then stop halfway. But then if you're doing a recursive descent thing, how do you resume that? It gets a bit funny. You could go with fibers and keep the stacks around. You could basically say, oh, throw that away and try it again later. Or you can have a dependency system where while you've been making the AST, you've been picking up on identifiers, just identifiers or something. And you can jot those down it for that function and say basically this function has dependencies of these identifiers, but you don't know what they are yet because they've not been defined. And then you can go over those dependencies later and be like, have all of these dependencies been resolved? And if they have, you can actually start to type check this function, right? Or so have these dependencies been defined yet? Yeah, because that is a problem with those sorts of things. Does that make sense? If you want, I can describe that again if you want. Yeah. To poll some events, we just want something like this. We want to like, right, so we're just calling into peak message. We don't need to peak anymore. Wait, that's iter next. While peak. Crap. No worries, no worries. Right, so that's just saying remove, and then we're going to throw it through there. So this, when you translate message or translate the translator, if it's got any sort of like, see, I'm not really sure about this, but if it's got like keyboard events or whatever, or something like that, and translates the keys, I'm not sure. And dispatch messages is going to end up calling that winproc callback. And then in here, we can probably send up the proper events. So I think we'll plug it in a bit properly. So this is going to go while peak message, but the problem is it could be posting multiple events in a single one of these. But I think for now we're just going to assume it only does one. But we'll leave it to do there, right? Because it's so easy to forget that sort of thing. So poll events, there's this sort of check we can do. The whole job of this is to put stuff in the event queue. So the to do would be like dispatch to do see if dispatch message can produce multiple events and then place. So this is very easy to check, right? You just take the count before and you check the count after, and then you can just do it. You can put an assert in there. Wait, so why don't I just do that right away? Right, so the idea is we want to say core debug assert. So we take the count before. Previous count. And then you want to say, hey, can you check if previous count, it's got to be sort of like plus 1 is less than or equal to, something like that. Expected dispatch message to only be pushing on a maximum of 1 event, but we got more. Please adjust the the if statement at the start of this loop to return, so we don't overflow this event queue accidentally. Because, you know, one of the pros and cons about this event queue is that it's a array that grows, but it's only allocated once, meaning we don't reallocate it if it overflows. So, pros and cons. Like that. Cool. So we just want to say something like that. So I want to make sure that the new count is cool. Right, so now what that's going to do is call into this winproc thing, so we can get rid of this little stubby thing we had, right? And we did... Right. This is very old code, so I want to get rid of that. Wait a minute. When called via peak message... Oh. I don't care. Rightio. So the idea would be if the size changed, so the beauty is we have an OS internal header, and yeah, it's in here. Good. So we've got these lovely queue event functions. So the different OS backends, so on Linux can call it, Windows can call it, and it can queue an event. It queues the event. You just have to give it the data, and it will just put it on the queue, all for you, nice, and adjust all the internal data. So as an example, right, if you resize a window, it will set correctly the fields in the event, but also update the global information and keep the size of the window around as well. So that'd be really nice. So we're going to take this one, and yeah, so it means we don't have to repeat it throughout the in the different backends, right? So we need to basically make a it's an S32, yeah, S32 times 2, low word lpram, high word lpram. Rightio. So we're just going to say window resized. Excellent. Next. This is like key pressed. Yeah, I don't know. Let's just get rid of that one. And if you close a window, we'll drop that in there. Is that a thing? Window close requested, right? So when you close the window, you're requesting that you close it. The application can shut it down, I think. I think there's two different ones. There's close and there's quit. No, quit is different. Quit is that the application quits. Close is like I've closed a window. So right. Maybe that's a really dumb name requested. We'll think about that. Right, so I think this solves our problem now. Basically, it's just going to run, and Windows is going to think our application is live because we're pulling from the event queue, basically. Oh, what is this? Get out of there. That stuff, please. Right, so we need to get the window. Windows, window. Windows, window. Give that a run. Ah, man. Okay, so just don't return that. So is this going to be true now? They've got the same error here again, still, but game has crashed. Please check the stack trace file. But I don't know. We don't have the logging system set up yet. Okay. Okay. The Windows segfault handler, did we set that thing up right? I wonder about this message box thing. Right, so that works. That's good. That's good. So it's calling the segfault handler. Surely we don't have this set up. Log. Wait, is my logging system working automatically? I didn't even have to plug it in. Right, that was pretty good. So I used this library to do the stack traces. We already had that. But I think... Oh. Right, so the reason why I thought initially we would have had to have ported to Windows is because we would have to get it to go out through the terminal, but we just put it out through the files. So the way the logging system works is it's purely built on top of the OS layer, so we don't have to worry about it. So when we log, we simply just write it out using the standard C functions, right? We've just done it like this. Yeah, bstack trace is amazing. Like, it's not like a well-known library, and I'm so glad that I searched for it and found it, because it just does the stuff that I already would have tried to do anyway, and you can just drop it in. And I've got it. Yeah, I got it when we crash, which is super decent. But I don't know why it didn't want to work. Like why it didn't want to load these up in Visual Studio. I have no idea. Yeah, it's just amazing. Bstack trace. OS input has some stuff. Oh, this is a log. Excellent. Did its job. But yeah, so we got this sort of poll events 248. Peak message. It crashes, which probably means this isn't. I don't know. Take a look. Come on. So we get this already, apparently. Which is weird. Yeah, it looks a little bit buggered to me. Do we run open window? Surely we must run this first. Yeah, and we run the windows open. What are you talking about? They're set to null. Then you get set to like, oh, okay, maybe. Maybe it's fine. Alright. That appears to be doing something. The question is when we're in win main, then does the game, so this is the entry point. Then we call our game main. You know, we need to get the command line arguments to come out, but it's fine. This still happens. Right again. Right. So something might be going on. We should probably close Let's close all tabs. Try again. Same problem. Now we're going to close Visual Studio. I don't know what I've moved. So let's take a look around and see if there's any sort of like... So got this x64 folder. Let's delete that, right? This is .visual studio. That's kind of like my settings, I guess. I want to see if there's something we can, like local cache that we can delete. That might help. You know, I don't know. I don't know if I've moved anything. Like we're just building an exe with the whole game in it. So I don't know why. We've deleted these before. So I don't know why it would be crashing exactly. Right, let's try and boot it up again and see. Well, no, I'm not sure why it's telling us that there's a problem opening the file. We might have changed the build script. Take a look at that. So let's compare it with the other build script. So basically, so we've got these flags here that we all set, right? Then we make sure the build directory exists. Right, that's fine. So we run HCC, which is our C compiler for shaders, right? We build our thing. And then we simply run Clang on the game. Right, nothing too different. I think we have a startup a startup? I'm not sure. Like a startup file maybe. Let's take a look. I'll try and remember all of this stuff. Yeah, so we run this this bat file. Then the output is game.exe. It's making a PDB file. So that's not out of date. It actually makes a new one. I'm not sure why we get this error. When we boot up the game for some reason. Good point. Depends where it's in, right? Depends on the context. It's passing into Clang, so that's not a problem. Yeah, that's not a problem. Wait a minute. Yeah, I think when you pass it into Clang, it's not an issue. It's something. You know, no, it could be though, right? But I don't know if I've changed. That's the thing that I've changed or not. I don't know what document it's trying to tell me that's opened. We could run it through the command line maybe and get something. Remove the hidden VS folder, try it again. Right, so we'll delete that local VS folder then. Follow the instructions. Right, so it crashes there, that's fine. What are we doing? Deleting that one. Oh wait, close that. Try to delete that one. Weird. Just give me like a fresh, like it's gonna not remember all my sort of local settings, I guess, anymore. Oh, sweet, that fixed it. That's a bugger. Because I think I changed some of the like the grayed out settings maybe. No, maybe that's global. Okay. Right, so now I've just got this crash to deal with. Why have I got a crash? Something to do with peak. Peak message. So check the stack trace. So basically, right, what I want to do is have my log files here. So if I go into /m mount c, so using Windows subsystem for Linux because that's what I know. And we're going to go to our workbench. I don't know. Yeah, workbench. Game that engine. Build log. So we've got this lovely logs directory now, right? Every single we've got these things called tags. What a tag means is basically like a category. So you can log to a tag, right? And it'll print out to that file. We've just decided to do something really stupid and simple. So basically what I want to be able to do, so when we crash, you get a stack trace. So is tailed -f, we can just keep this file open. And whenever we get any new changes, it will show us in here. We can have many tabs open for the ones that we care about when we're debugging, basically. So yeah, this is going to be used for search. You can tell if I were to make any changes to this log file. Save it. Well, I thought that would work, but it doesn't want to. Is it tail -f? Let's man these tails. Follow. Oh, appended data as it grows. It is appended, isn't it? Yeah, maybe not deletions. Right, so as the file grows. Ah. Maybe not good then. But I guess if we rewrote the whole file, it might be fine. But anyway, so let's run it again. Do watch cat. Fantastic. What does watch cat do? This might be better. Man the watch. Oh, it worked. Oh yeah. That's exactly what I want, is a live stream of that file. Beautiful. So we can just leave this thing here and we can just get updates to this. Thank you so much for that. Look at that. Gives me the time. This looks amazing. Awesome. So yeah, we can just get the latest update here. Don't have to worry about leaving, you know, because in text editors, they kind of ask you a question. Is it, so they ask you like a question like, oh, the file changed locally, do you want to reload it? But instead we can just have this window here and it'll work much better. Let's man this watch. Oh. Execute program periodically showing the output full screen. Runs it repeatedly. Such a great solution. We'll run every 2 seconds. Okay, okay. Fair enough. Computers are fast, no worries. Yeah, it's cool. 2 seconds is good enough. That's amazing. Thank you. Wait, does it give me the update? Oh, so it tells me when it... Oh, okay. No, this updates. Right. Careful. That's cool. That's fine. Right, it's good to know. Wait. That'll be useful. Thank you so much. So what's the plan Now, so what fixed the problem? That's the plan. So it's saying here, poll events 248. Oh no, an assert. Maybe the something isn't initialized yet. We'll take a look at that. So poll events. You know, maybe it does run, right? Let's take a look. So we're just gonna follow it through. Does it crash? No. That line number's a bit off, right? Yeah, this is a little bit wrong. So maybe it doesn't push any events on. What do you think about that, did we? Wait, is this just the wrong way around? So it's as if we want to do like a takeaway and then make them signed, right? So it'll be like, this one is probably bigger. Wait, no, sorry. I want to say make sure this is, wait, no, this will never be negative, don't worry. Less than or equal to 1. There we go. So we just changed this number here. So we might change this here instead to be like a takeaway thing, right? Take away the capacity or the count from the capacity. And if that is less than 1, we're going to return. So now we have changed this one field basically. Excellent. So that should fix that problem and we should have a running application again. There we go. We don't have any continuous loading bar anymore. So I think that this, by running this code, basically kept Windows happy. So here's the game running again. It's just running 3 compute shaders laid on top of each other. Nothing fancy because we're going to be doing that graphics stuff later. But now we're ready to actually start implementing some of the OS stuff now, right? So we've got it all together. So I have some examples that have been given in the Discord channel by Mr. Nodillo. Or No Idea. So he's given me, like, we did this game jam probably over a year ago now, 2 years ago maybe, I don't know. And he did this layer on top of this input layer on top of Windows, and yeah, on top of Windows, but yes, like a platform abstraction for like input, like mouse, keyboards, and gamepad. So basically, this is the interface for it. We already have our own interface that we've done. So we just want to take a look to see how he has done this, so we can sort of just see some sample code basically, and it'd be a big help. So we probably want to start with something like the mouse. I think it's doing a raw input. So like on the, our interface has 2 different mouse inputs in a way. It has the sort of the raw mouse and the virtual mouse. So you can, if you plug multiple mice in, you can get in the individual mouse cut, the individual like information from those mice, but it's basically like a relative coordinate, right? It's a relative position. And then we also have like what's known as like a virtual mouse. And the virtual mouse is basically the OS cursor that you see moving around, and this thing has a position on the screen, right? Or maybe a position in the window, I think I've got it as. I don't know. Kind of forgot. But yeah, so we want to have those two things. So I think this sample code uses the raw stuff, which is great because this is probably the harder thing to figure out maybe. Yeah, we'll be looking into this. And seeing how it's done on Windows. And we probably want to figure out like how do you detect plugging mice in. So it might be best to check this input device add. Interesting. So we'll just be taking a look at this basically. So type mouse. Here we go. This sort of stuff. Here it is. So we might have to subscribe to some events maybe. This is probably part of the event. Yeah, the WinProc. Of the WinProc function. Excellent. This is going to be amazing. Looks like solid clean code for IO. Input output. So many I, X, Y, Z device. Yeah, I don't know. I think IX is the prefix, right? So it's just called IX. Maybe input. I'm not sure what IX meant, but yeah, it's just a prefix. Yeah, I think Nodilla uses the raw input for the keyboard and mouse, and then for the gamepad he uses the raw HID stuff, like human interface device stuff. But I think the human interface device stuff is used to detect them being plugged in, which is super nice. So this seems like it might be easier than the, well, it might be similar to like the UDEV stuff on Linux, but it might be a bit easier actually, I'm not sure. But yeah, we'll see. Right, I'm just gonna quickly pop and get another drink, but I'll be back and then we'll resume basically just using the sample code and bringing some of it over. And we'll probably start with plugging in different keyboards and mice. Yeah, start with that. I've got a spare mouse over here. Let's unplug that and plug that back in. And we've already got the sort of internal code to actually like deal with when you, like we've got events, right? So when you plug something in, we should just be able to call this input device connected and it will just set it all up. Like literally just sets it all up. We just say, hey, this is the name, here's the key, here's the features it has, what's the vendor ID, the product ID, and just sets, it adds the new device and event and everything for it. So I've already done all that stuff, right? So it should be a lot easier. Is there any big advantage using raw input instead of straight WM messages? So I don't actually know, but I assume that it doesn't have to go through the window layer of Windows. And the same is for Linux as well. I don't know how much quicker it actually is. I don't know if it will end up there a frame earlier or 2 frames earlier. I don't know. Like, but presumably it doesn't have to get read by the window layer, go through their system, and then come to you again. You know, depending. Yeah, I'd really have to try that out. But yeah, the main benefit is that you get to read basically you get to read the data from, yeah, like for the gamepad specifically, the main benefit is you get to read kind of like, well no, gamepads is different. Yeah, right, yeah, I'm not quite sure what is true, but I think it might be better to read from the raw stuff anyway. It'd be good to test it. Yeah, you can go through X input, but I've heard there's basically there's no good solution on Windows. Each one of them has its own quirks, which will which we'll go over in a bit. Because I think I've heard you basically need to like, yeah, it's really silly, just all the different quirks. Assume Roy, you don't have to translate message equivalent text input if you need it. Yeah, that is true. But I think in this abstraction, we're just doing all of them, and you can just read back. Yeah, we read back all of them. So I don't know if we're actually saving any time. In fact, we might be adding more time by doing all these different class events, maybe. But yeah, I don't know. It'd be good to test out though when we have something. Mainly, I'm just trying to provide all of the features so I can just sort of like when we're prototyping, we can just switch between them. That's the main sort of idea I have with this right now. Yeah, I'll be right back. I just need to grab a drink. Anyways, enjoy the tunes, and then we shall resume in a minute. Hello, welcome back. Wow, it's okay. We're just gonna deal with glitchy me for now. Bit too light still. Oh, my days. Yeah, I had a thought actually. Why do you do raw input over standard Windows one? The reason is, well, at least on the reason why we did it on Linux is because you can't detect multiple mice or multiple keyboards, like different keyboards, different mice, using the standard OS, like going through X11. They sort of combine into a single one, kind of. Um, so yeah. Whereas, and so maybe it's the same thing on Windows. So maybe that's another thing. I was thinking using raw. I always think on using raw input and end up using window manager messages. So I'm asking a curiosity, right? Yeah, that's cool. Yeah, I need to learn some of this stuff myself and just see exactly what the pros and cons are. But yeah, um, radio. So the basic idea is we need to. I think we want to start off just getting this sort of code in, right, where we can like just detect keyboard and mouse and gamepads being plugged in, which would be pretty cool. So there's this sort of like WM input, and then it does this sort of like extended stuff. So I don't know. So we've got to see if there's any sort of subscription-y stuff you need to do. Maybe it just gives you the events. The window gets set up, it just gets created. So if you compare that to my one, I don't know if there's really much in it, really, to be honest. R&D proc thing, what was it called? Yeah. We did kind of use a different way of doing it. Sure. I I don't think there's anything special. I think these things just come through. So yeah, I guess like we don't need to say, hey, subscribe to this event. I think it's just already doing it. No, some Windows abstractions put you closer to the bare metal than you further away from it. Right. Right. Yeah, I guess it's difficult in Windows, right? You don't have access to the system calls, right? Whereas on Linux, you kind of can interact with the operating system through the system calls. Well, that's kind of a lie. On Windows, you can, but it's kind of undocumented, right? But yeah, they have the sort of like Win32 API, right? And you basically have to understand like what is built on top of what in that layer, in that library. So I guess this thing is like, all right, this opens up a window, and it doesn't really do much. Okay. So anyway, I guess we can just like, all right, let's do this, right? So the idea, go to R1 now, our WinProc thing. This is the thing that parses the events. So this sort of like input one, right? Now the idea is that so I saw this device change as well. Ooh. Ah. So this is if you right. This is receiving input events. This one is receiving plugged in devices being plugged in. Okay. Okay. Radio. We got this. So the idea does he use spaces or tabs? Right, the tabs. Good man. Good man. We can just copy paste this. Maybe it's yeah, he uses tabs. What a true programmer. You know, 3 less bytes. Who doesn't like tabs? Right, so I guess you get this thing called a handle H device. Whereas the device handle, we'll call it device info. Do you make this structure? You set the size of it, right? So I guess the Windows implementation can tell, and it just adds more. So I guess if Windows wants to add more fields afterwards, it can. Basically, that's the idea. So there's this sort of like, yeah, so if it wants to add more fields afterwards, it can. But for backwards compatibility, they sort of ask you to take the size of it in or something. Cool. Right, and then they ask you to pass it into the function as well, which is kind of funny. Right, so you're saying, hey, get me the raw input device info using this device handle, and then we can process that information. You know, I like doing that, so I want to just refactor that like that. Mostly looking good though. Right, so what else do we need to do? Is this like a right? We probably want to use the A version by default. But let's be explicit about that because there's like a yeah. Right. So A means ASCII, W means like wide char or something. It's weird. Right. So basically, you get this result, and there's some form of like error. Typically, I don't like doing this because it sort of like tabs it in. Typically, what I would do is invert that and then just do a break because you're inside of a switch statement, right? Just do an early break. Um, so what I would do. So the problem is. Mm, so maybe we should do like a return 0 instead. So what we're saying is like, hey, if res is equal to this, and I typically let's put the variable first, not the constant. But anyway, no worries, no worries. Or if it's equal to 0, something like that. You just flip it the other way, then just return 0. Then we can actually like process this properly. So we could go ahead and look at the docs. Um, so it just gets the device information, right? And the return parameter. So if successful, returns a non-negative number, indicating the number of bytes copied to P data, which is that structure that could change. So obviously 0 is not good, right? And then it could return. Right, so this is something in Nordillo's thing here. He likes to declare that. That's fair play. But I think I might just. Right, maybe that's a repeated pattern. So we should really just save if it's. I see uint and these things. Right, I might switch on that light. It is getting really dark in here. There we go. Now I'm not flickering everywhere. So returns -1 if P. Right. So we could cast into like a signed in. Press compile. So I might cast into like a signed in. I might just say int if that's like less than or equal to 0. That's an error. No, because it's kind of -1 or 1, isn't it? So really, actually, you know what's good? Just do -1 uint all that, I guess. Fine. Because technically, if the structure gets big enough, which it probably won't, right? It's wrong. Just check for the 2 states it could actually be. Then you call get lost error to identify any other errors. Okay. Hmm. Right. It might be good to silently fail, but maybe we should keep... Yeah, I think that's fine. Okay, so what else doesn't happens from here? So what we find is cool. So then we switch on this param here, and there's this saying arrival and I guess like removal. Okay, so arrival or removal, and from that we can tell if something's been plugged in or unplugged. Now hopefully this runs like when you start up the application, hopefully it'll be nice if the devices that are already plugged in run through this thing. So we're going to test this out. We might just do some quick logging. No, we'll just call our functions, I think. So wparam, let's just give us a quick little just produce the lines of code. DW type. So it's a mouse. Do these things. Right, so plug in a mouse, add a mouse device, keyboard device, or a gamepad device, that sort of thing. Cool. If you remove it, go the other way around, right? That's super nice. That's what we want. Tab it in. Much better. Got to tab all this in a little bit as well. Untab that. Right, much better. Improving such deeply nested switch statements looks painful. Yeah, definitely so. It was not easy. It's okay that you got these things, I guess, these little guides to figure it out. But yeah. Bit painful. But yeah, hopefully. Yeah, there's so many. Oh, there's still more to go. Yeah, I don't like the braces going down on their own line because it just adds so much verticalness to it, and it makes these things harder for me at least. And sometimes I do like the cases to go inwards, but then it kind of just. I think I liked it for some moment in time, but then I went back to indenting things, even though it does make it twice as much on the switch cases, you know. Yeah, pros and cons, you know. Right. Yeah, sometimes if statements might be easier, I don't know. Default break on one line. Yeah. It will save some lines, you know. But I think the reason why you do that is send the debugger, right? You know, they know if it's a difference between testing the default, maybe. I don't know. Maybe. Maybe not, actually. Not sure. Right, so this is super nice. We should be able to plug in our own interface, right? We've got these lovely functions already because we've done it on Linux already. So we should just be able to do our own version, but it's going to be different to Nodillo's here because, um, yeah. So I might see with so many layers deep in these switches that sometimes I like calling into a function, um, even though it's only called once, right? Um, how does the Linux code look? Right, so when we do this device connected, what does that do? So on Linux, you are right. We kind of like, oh no, this is the iterator and when it's initially connected. Yeah. So on Linux, the problem is there's actually like two places where it can be called, so it's put into a function anyway, and we basically have to use udev and enumerate over all the things. Whereas on Windows, it's probably just going to give it to us via these events anyway. But yeah, we'll think about that. So what we should be able to do is this device connected. What is the key? Well, the interesting thing about the key is I think it could just be the device handle. So a key is like, how do you uniquely identify this device from any other device? Um, and on Linux, we use dev-t. We use device number, get the device number, pass that in. Whereas on Windows, we can just use the handle, I think. That should be good. And that way in the hash table, is that right? Wait, why do we need the key again? Wait, why do we need that key again? There was a reason. Right, yeah. So we have a device find based on the key that gets you the device ID. Or the device, rather. Yeah. Gets you the input device, basically. Translates the OS handle into our handle ID. Did I miss one? Oh no. Have a look. Your Robbie is a function pointer based jump than a deeply nested switch. Hmm. Yeah, but then the readability gets bad as well because you're jumping to different places in the code. So it's kind of, I like sometimes just being able to scroll through the code even if it is a bit difficult to read. Um, yeah, so mm, it entirely depends on the code, right? I see the point though. Not a bad one. Oh, that's fine. Oh, I did. I missed one. Ah, good catch. Right. So what's the name of this device? How do we get that on Windows? So we could obviously skip this, but it might be easy. Um, Dummy union name? Do they really do that? Oh, wow. Because that means on C99 you'd have to use that dummy union name. Oh. Um, right. So on Windows, how do we get the device name? Get raw input. Those jump tables are a thing for generated before switch. Right. Yeah, you know, there's a feature that I really like that's in GNUC, and you can basically have like a label. Um, I guess this is really good for like interpreters or whatever. But you know, you have the jump. You like in assembly, you can jump to an address, and they do it all the time. So you can basically like say label, and in GCC it's double ampersand label you have to do, um, something like that, and that basically takes the address of a label, and then you can just say go to dref label pointer, and it will jump. It will jump to the label, so you can basically like store these pointers in an array and then do a lookup table, grab the pointer, then jump to the correct label programmatically, which is like super cool. I really like that feature because it's kind of like in assembly anyway, but you don't really get access to it. Yeah, that's really nice. I do like that. I wish that was core in core C, you know. Then you can do some super. You can do those jump tables yourself. How do we get so Win32 raw input device name? That's what I want to get to the device name somehow. Jump outside the function scope. Oh, yeah, that's quite dangerous though, right? Because the language, like you can already do it with long jump, right? But you can only go up the call stack, which is safe. And then across though, that's a bit nasty. You can swap out the call stack though, and do like a go to another function and jump back. That's kind of how like the fibers work, right? Is they change the instruction pointer and that's another safe way of doing it. Oh, okay. Uh, so we're trying to find a way to get like the name. You thought it would be device info, right? But it's not. But there's also like list devices. And these give you like a device list thing. Not helpful. Um, yes, this one we've been using. But it's not anything. Oh, device name. Oh yeah, so we can do this, which contains the device name. Fantastic. So we've got to call this again. Farmadays Windows. Why didn't you just do this as a separate function? It's like, oh yeah, you can use this function and just call it a different thing. Amazing. So the problem is you want to do a different points to a string that contains the device name interface. Surely it should fill it out. So we need a size. So I think what we did is we had a max size and in the Linux one, right? Where is it? Yeah, so we've got like an input device name cap. So I think we just have like a name buffer, and this should work. So I guess if the name, we don't really care if the name gets set or not, right? So just do it. Give us the name, please. Name buff, and then like size of name buff. Bear in mind we don't take the address of these guys because it's a array, so turns into a pointer anyway. So that name buff should be filled now. So we can actually have the name. Course string name equal course string C. That does a string len basically on it. Makes that course string for us. Very nice. So now we've got this here. Bear in mind that we only really want to do this when you connect the device anyway. Right, so it goes in here. And hopefully that works. Fingers crossed, but there you go. What sort of features does this device have? Then it's a mouse. Now, so hopefully, yeah. So I don't know how good doing it this way is because, how does this work? It's got a touchpad. Does it show up as a mouse? Does it show up as a gamepad with, because the way my abstraction works is that an input device can have multiple things on it. It can be a gamepad, also have a touchpad. So I don't know if this system is going to work. So we're just going to have a feel, just write some code, test it out, and make the changes. Maybe we have to do something a little bit more complex. So we're just going to say device features mouse for now. What is the vendor ID? Good question. Well, I think that has been filled out via this thingy here. So I think we might be able to extract. There's an ID. Yeah, this is what we want. This sort of like HID info. Where do we get this? So the HID info. Where do I get this? Does Nodilla have that in his code? Have a look in Nodilla's code. He doesn't use that HID information for some reason. Okay. We're going to see how we get hold of that. So I think... Wait. How do we get this? So the docs say... absolutely nothing. So there is this one. Oh no, there's a HID union. Oh no. So right. So maybe there's generic. Okay, so you can get mouse through this HID thing. Yeah, maybe we'll switch on it here because I don't know if any of this is useful actually. Any of this will be useful. Number of buttons, maybe. Maybe it is. Keyboard mode. Not sure what that is. Maybe that is useful. So it takes the number of buttons basically and zeros them. Keyboard added. That's what his code does there. If the mouse gets added, just allocates the number of buttons, but we've already maxed that anyway. Yeah, I'm not sure how useful that data is going to be, So we might just still do what we've done, but just change it a little bit. So we're going to have mouse and then keyboard. So here's duplicate this. Visual Studio. Doing too good of a job. Mouse. Keyboard. So basically we want to take this code here that we've been kind of doing, and drop it down here. And then we want to, there's this sort of like vendor ID thing. This vendor ID will be in hid vendor ID. So device info, hid vendor ID, product ID. So we store that in our abstraction just because it might be a bit of fun. There might be some gameplay things we do which is very subtle, where we take those vendor IDs and product IDs and maybe we do something very subtle in the game, or maybe do something quite fun and interesting. We don't really know yet. So maybe we could simply just set the color of some item in the game because you've plugged in a particular device. Maybe we do something else. But yeah, it's just an idea, so we keep hold of that info. I think that would be a nice thing to have a bit of fun with. So there's also more things we need to fill out, like device-specific things. So we should probably look into that. So I think we need to store the handle in this input device. Then the Windows internal, we need to have a handle here. So in this Windows input device, we need to say handle device handle. So that's void star, which means these need to quickly change to 8, 8. And then what we want to do is have a function. So in OS Linux internal, we have a function that casts a input device into a Linux input device. That gets the sort of backend specific data. So we just need one of these for the Windows side of things as well. So just going to find this function, drop this one in here, give a bit of a rebrand. And basically we just want to say, can you cast input device backend data into this guy here? And then we can just call this whenever we want. And we kind of want to do it where we were. So we kind of want to get the OS Windows input device. And basically we'll just fill in that one thing for now. We're probably going to add a lot more into there. I just don't know what that looks like. Yeah, it has been a lot in the past. Like for instance, here's one we've done before. We've added like all these different string path names, so where we can like read the specific events back and their file descriptors and the bindings for those things. So yeah, maybe there could be some more. It could be a lot more simple in Windows, we don't know. I think that's a good start. Let's go ahead and copy and paste this and do it for the keyboard and the gamepad, but no joystick. We don't care about joystick. So one thing that I want to be aware of is when we get this thing compiling, it should print out in the term in the log file, hey, you've connected this thing, disconnected this thing. Because I think we'll do a print. This isn't ideal. We should use the new logging system, I think. We haven't converted over to that yet, but we're going to take a look at that. Because printf doesn't kind of work on Windows because we use the GUI kind of main function. So I haven't allocated the console. I'll change it to gamepad. String N copy versus string L copy. I don't know the difference, to be honest, but I know the C string functions suck. So you're better off making one locally and using that one that puts the null terminator on the end always. Because string N copy doesn't put the null terminator on, but string L copy, it might do that. But is this one utility functions on BSD systems? So I guess if you're making it cross-platform, it might not be a good idea to use this. Does it put the null terminator on it? Guaranteed to be null terminated. Yeah, so maybe use this one if you've not got cross-platform worries. But you might as well make your own that does this. It's not too difficult. Yeah, sometimes it's better to like take. Is it? I didn't know that. Is it available on Windows? Is it really available on Windows? Yeah, it looks like GCC still. I'm not sure, but yeah, like I would probably just roll my own string function and just use that one. At the end of the day, it's just a mem copy, isn't it? Right, so that's device being added, which means we can just delete all that now. Yay. So when you disconnect the device, so it's basically the same thing. The formatter. Oh, it is. So basically we want to instead call remove or disconnected. Disconnected. Disconnected just takes in an entry. So let's look at the Linux internals for that. Disconnected. So if you disconnect, you want to find an entry based on the key. You find an entry based on the key. If you have an entry, call disconnect for me, please. Kind of done it in the wrong place. Let's take this one. See, we don't really care if it's like a keyboard or if it's a mouse. All we care about is if we just care about removing it if it exists, right? Nothing too crazy about that, you know? We just want to pass in the entry, and that's basically it. Right, so delete all that. Much better. Let's hide there now. Then let's push this to GitHub. I'm going to take a closer look. Yes, we do have it available, but it's only available to people who are Twitch subscribers or support via Ko-Fi. It's much better for me if it's supported via Ko-Fi because more of the cut comes to me basically. But if you prefer Twitch, that is cool. But yeah, I'll leave a link to some more info about it if you check on the Discord, or if you scroll down below, actually, in the About section, you'll be able to take a look. More info about that. But yeah. And the reason why I put it behind a paywall is because I do want to ship this thing eventually. So the idea is that, so there is a license to it where basically you can read it, study it, be like, you know, but you can't like basically copy paste the project and sell it, that sort of thing. So you can like learn from the code base, but you can't really just like wholesale copy paste it and just reskin it. Basically, that's the idea behind the license, at least. Like, it probably isn't a problem if you just copy and paste like a small section of it, and obviously copy and paste a section of it, refactor it or whatever. But like, not to like steal the game. Basically, is the idea behind it. Obvious input device, find entry. So we should be able to do all that there. That'll be good. Alright, so should we try and see if any of this actually works? So let's press F5, see if it compiles. Now, I think on my days we have things. So I think we haven't got any we haven't got any, maybe we haven't included the right headers? Maybe we have. Ugh. We've got to cast it's like an int. Oh, it takes an address. Ooh. Ooh. Alright. Should we do that? Yeah, that goes. So we don't have this hid sort of whatevers. So this is in a hid usage.h. So I think we need to include that. So if we go into the sample code we've got from Nodillo here. Yeah, hid usage.h. Right, so we need that one. Alright, so we can drop that in the header. I'll take the address. Sure thing. So this key, incompatible to cast between those things, fair play. So we need to do an cast manually. We do any of that stuff, no biggie. Right, so remove 4 or more errors, very nice. This one is complaining because reasons. It's not declared? Did we put that in the header? We didn't put it in the header file, so it wasn't forward declared. Therefore, it didn't exist. That should fix a couple errors. This one is then saying return from non-void function radio. Okay. Right, so the game is now running. Nothing is printed out into here because we kind of need to use like output string, get it to come out into this thing, I think. Should we test that out? So we don't really have printf working, obviously. So let me just try this quick. Output debug string A. This is a test. So that should go in the terminal, I think. Maybe. Alright, it does. It goes here. You see, it only goes in this one though. It doesn't go into this one here. I don't know how you can get stuff out into this window. Yeah. So I think we might as well disable. I think there's a way to disable that window because it's really pointless, and we should remove all printfs. and just use that logging thing, right? Because we've got this window here where we can, or this terminal, where we can just basically, we just cat a file and we can just view it in here. So I think we want to remove that console window from actually opening. So I think that's in a tools options. So there's like a console. Can you change show output to debug? Maybe. Let's try that. It might not be in here, right? Hmm. Oh, the sub window. Gotcha. Gotcha. No, I don't know if it is there. The list of the DLLs. I don't know what you mean. No, this doesn't say anything. Yeah, so I kind of want to like stop showing this. Like, Rust compiler, thank you. Maybe we could do that. Yeah. Um, so we could redirect it to standard out. Um, redirect standard out. Yeah, so maybe there's alloc console as well we could do, but I don't know why this console window shows up, you see. I'm not calling alloc console. So you should change the type of project from console to in the settings somewhere. Okay. Right. That makes sense. That makes sense because we are using a like a GUI type of one, aren't we? But it's the project. Yeah, because it's saying local Windows debugger. No, that's not right. Tools options debugging. Let's take a run there. Yeah, subsystem. That rings bells. But maybe that could be in the compiler, not the debug in the system. Yeah, that's it. Yeah. Um. Output window. Maybe. Maybe not. Um. Don't know if I can see it there. Add link parameter m console. Yeah, but I don't want console, do I? I don't want a console app, do I? Yeah, I don't know what's a good idea. Should I use console app? I'm not sure. Because I can use the console app, and then I could always create a window anyway from that. Like, you can always create a H instance, isn't it, or whatever it is. Yeah, you can still have a window, isn't it? I don't know if I did use it. Yeah, I could add that in. Oh, here it is. No, no, it's not it. Uh, right. Hmm. Yeah, so maybe there's a way to like remove the window, like it's like a you'll open like a command line, you know. Um. It's not really called a terminal anymore, is it? Well, in Windows at least. Console. Not quite the same. Yeah. I swear I could have swore there was a setting I've changed before where you can stop that. So Visual Studio stop console window from opening, not closing. Automatically close console when debugging stops. That's not it. It's the debugging console. Don't open debugging. But is it because of this? You're launching the debug. That's debug panel. It's not the same thing. Yeah, it's only a little bit annoying, but I was just wondering if it was easy to change. But I don't know. It seems a little bit more complicated. Debug. Automatically close console when debugging stops. But we want it to stop opening it. Yeah, but I don't know if that exists. Property pages. Linker subsystem. Yeah, I don't know. I've got a bit of a weird setup, a weird project setup. Let's go to the correct. Or do I have to log into? Huh? Yeah, I want to use the con. Yeah, but I've got a bit of a. Mm, I haven't got. I've got like a custom. I don't use like MS Build or whatever it is. I just run a batch script, right? So this is all very neutered, right? You have a very sort of neutered thing. So it's not. It's all controlled manually. Yeah, but if I pass M console, then it boots up with the console, doesn't it? Do I want... Yeah, maybe I'll try that. Let's try it. You're saying if I run with M console, and then I've got to convert to a console app. But then it means I can use printf randomly. But I do also have the logging system, which we should really just be using the log system anyway. And I want to... Yeah, I really just want that window not to show. Yeah, but I don't know if that's really going to help. Let's try it, right? Where's the scripts? Yeah, I don't know if it's going to help though. So I think I've already got subsystem, haven't I? Ah, maybe I don't have that subsystem windows. Yeah, so I can't do slash though because it's not MSPC, it's Clang. So Clang Windows subsystem. What you saying there, Semi? Right, so you're saying free console, alloc console, attach. Yeah, so I could do that if I want to get printf to work, but I don't ever really necessarily care about printf because I got my logging system, which logs out to a file. Right, dash m Windows. But yeah, I might be a. Let's try this one. Dash W. Right, still got some link over args there. Do some more. Let's see how that goes. Unrecognized dash dash subsystem. Is it just dash subsystem? Let's try dash m Windows and see what happens. Nope. Where did that music go? Um, they're doing this dash dash subsystem thing there, and that works. And there's apparently. Let's try a console and see what happens. You mean to do like a colon? Right, so that seemed to have worked, but it's saying that the main function is not declared. So if we do that, alright, it still launches it with this window though. Right, so that didn't work. Yeah, I might just leave it alone and see if I can figure out some other time. Because it's just a little bit of a nitpick. But yeah, there's a way to stop, like, prevent C++ debug console. Disable debug console. In the project linker settings, set slash subsystem windows. Yep, done that. Entry. But we did that, right? But maybe it's this main CRT startup thing. Should we try that? Yeah, so I think the Visual Studio thinks it's a console. Try calling free console. See what happens. Win main. Ooh. Have you just found it? Diagnostics. Yeah, this could be it. No. uh, I'll turn that back on just in case. Yeah, I tried it with that just a second ago because I got it to work. Yeah, I tried it with that C like that. Wait, they did dash dash, wasn't it? Still don't work. I tried it with just the dash and the dash dash. I have a win main. Right, let's keep that there for now. So where's my win main? Let's do like a free console in there and see what happens. Don't work. They will hit it. There you go. It's there. Um. Yeah, but my linker sentence doesn't show up because I got like a very neutered sort of special setup where I use nmake or whatever it is, where I manually provide. Oh, sorry, I do make file configuration, so I don't have the linker settings like people have. It's different. Yeah, let's try running it outside. But so it's when it's got the debugger attached, isn't it? Right, the game crashed because it wants the the current working directory is wrong, basically. But yeah, it didn't seem to boot up the console first. It's something to do with like, you know. So yeah, if I do something like build, yeah, so it doesn't run in there, but yeah. Oh, it could be when it runs the build script, maybe. Is that right? What is this? Not telling me much. Wait. No, it's running game.exe, but you can close it. So these flags are set through the Visual Studio GUI. Don't really have an effect. echo off in the batch. Yeah, but the batch script doesn't run the game afterwards. It doesn't run the game. It just builds. It runs the build. No. So what happens is in this build thing. Yeah, we're just trying to see if we can remove this extra window. There's a way to do it, but it just basically says, "Hey, run this," right? So it says on success, it's gonna this batch this build command line is gonna make this. Well, this file will be there, and then you can run it basically, right? So for some reason, this is running, gets ran in a terminal, but then it doesn't close. And it stays open. All right, I'll try and remove it, but guaranteed it won't work. Is it rem? There you go. No, no CMake, no CMake, no CMake. So it doesn't show up through here, right? CMake. Such a ugh. CMake. But yeah. So there's this options thing. Debug. No, same thing. Tools options, isn't it? Uh, nah, it's alright. That's Visual Studio Code. Hmm. So maybe it is this window, but we did disable it, right? Do we have to close Visual Studio and open it back up again? Do you reckon that's it? So disable this thing. Debug window, show diagnosis tools. Wait, what? Debug. That's this thing. That's not the same thing. There's nothing in there either. Hmm. Yeah, I think I might bail on this. I'll try it some other time. Maybe we'll find out some other time. It's a really weird issue. But anyway, not to worry. So basically, we want to change all this printf to log out to its own file, right? We've got a logging system. Let's just use it. So we've got this like OS input. Like where do we use that? So we just do as a test saying this is a log. Let's use it. So where are all these printfs being used? Right. That's printf. Oh, maybe not. But anyway, we'll just take all this. And what we're saying is that, hey, have you got printf for this? Yeah, so to give you a bit of an update, not so red, basically what we did is, oh my, 34? That's too much. Basically what we did is we simply, we've just written the code that will parse the events for checking if a device has been added or removed. And we just want to see if that actually shows up. We're just changing this to log out that data basically. All right. So that we then want to like check inside os.c. This one. Where's the printf? This guy. Let's change that. Device has been connected, disconnected. Excellent. So now we can open up the file. So I need to open up a new Ubuntu one. CD to the right place for some reason. Mount C. Users, me, workbench, game without an engine. And we're going into the build directory, the log files. Excellent. Watch. So I think we need to do a sort of because watch changes every 2 seconds, but this is very frequent data. So we want to say -n 0.1 is probably good. So watch -n 0.1. Then we're going to say OS. Oh, I think I just made it freeze. I don't have linker. Yeah, I don't have that. Basically, I don't have it. Because I'm using the make. Yeah, I use a custom build script. I've got it under the make file setting. So all of that is described within the yeah. Hmm. But yeah, it's all specified manually through the make file. Uh oh, I made this bug. I pressed tab and it's like I cannot complete. So I've got to reopen it again. Build log, we're in. Okay, so watch -n 0.1. Then it's something like, what is it? It's OS input. Huh? I've done the watch command wrong, I think. Um, Right, some examples here. Dash N. Oh, I need cat, isn't it? Oh my days, I can't believe I forgot that. Thank you. I just completely forgot about it. Thank you. Right. Sweet, so that'll be updating every 0.1 seconds now. Nice. So now we run it, we should see some stuff show up in our log file. Um, absolutely nothing. So we can start by plugging in devices. I've got a spare mouse here. So plugged in the mouse. Not picked up yet. Trying to control. Okay, so I'm moving it with the. But it's still not showing up here, which is weird. So perhaps maybe we've not subscribed to the event or something, or. Um. So somewhere in like. I was hoping we'd land in here at least. Do we get something that goes in here? Right, so I'm gonna unplug that mouse. It doesn't even show up in here, so maybe we're not subscribing to the event in some way. Let's read some docs. Because I could have swore that there wasn't anything special. Available only after the application calls register input devices. I'll register raw input devices. Okay, so let's look at the sample code we've got given. I've got a lot of space in there, you see. Right. So clean win. Oh boy. Clean win. Right, initialize. Hmm. Should it reload automatically in the in Visual Studio? Yeah, I don't know. It's good to have the log files in a different window though, so I can just like view it, I guess. Yeah. Sometimes it asks you it's changed locally. Do you want to update it sometimes? And maybe you can configure the editor for that, you know. So. So dev not notify. Do you go over all the different device types? Right. Generic mouse, keyboard, gamepad, joystick. Okay. So we need to fill up this like HID array, HID or input usage array or whatever. And then we need to give that to. No? Yeah, we need to give this to. Mm-hmm. Right. Let's grab this code. Let's give it a bit of a refactor. Let's put it in our code base. so we can get this event to work. So in the back end initialize, maybe before we open the window, basically we want to have this thing populated. We could probably just hard code it, not gonna lie. You have to have a window handle. Okay, so that goes after. So you basically want like a Windows window. Drop that here. So we're going to be doing this like 4 times or whatever. Probably 3 times. That's all we want. This would be OS backend. Wait. Something like that. So just want to initialize like an array, probably just 3 of them. So I think we should be able to get away with an empty initializer. Just do something like this. Input sync. I'm not sure what that will do. So one for the mouse. Need commas here. Comma there too. Be 2 more times. One for keyboard, one for gamepad. Is it gamepad? Yeah, it's gamepad. Cool. So we should be able to now just give this array. So we just want to call this like the, I guess they're like device types. I think they're kind of like device types maybe. So I've got this like core array count, so it just gives me the count of a array that we know at compile time. Basically. Sure. So if this fails to initialize, we should probably log that. We'll maybe log it through the logging system we have, right? So call log. Right. I'm not sure that mask does, to be fair. Let's just do something like, that's pretty fancy. Look at Odillo's code. He's got variable arguments with just a he's got a VA. Right, so he probably does, every variable argument would be the same type, and it's probably got some type info, so he doesn't have to pass it in there, maybe. Interesting. Okay. Interesting take. But yeah, we're just gonna split it as hex. Okay. So let's try that one out. Let's see what we get now. Absolutely nothing so far. Let's try and plug something in. Hmm. Right, what do we have set up? Device change. So we put a breakpoint in here. Right, so I've just unplugged the device, so I've removed it. So it's working better now. We are getting this sort of -1. Something's fishy, right? Yeah, was it hoping for like a hit? So something's up here. I'm not sure what we're doing wrong. Like, why can't we get this information? I guess we can do a get last error. Um, if p is not large enough, returns -1. If it's not large enough, it returns -1. But we've just done size of this, which is 32. Um, if it's not large enough, it returns -1, and what it did. So when we do this device info, it points to this structure. Um, add this to your Clang X linker. Yeah, give that a go. Let's give that a bit of a try. Right, so you're basically saying pass these to the linker, but in the sort of Windows way of doing it. Where's my build script? Right, that. Um, this only can't find the main file. Main CRT startup. But we're kind of, it's on WinMain, right? But I guess in WinMain, what's the stack? What's the call stack like, you know? What is the call stack? It doesn't tell you. Apparently it's the first function it calls, but I guess it defeats the purpose putting WinMain in here. Right? Weird. I get a bunch of link errors. I don't know. Let's remove that and see what happens. Wait, did that work? I think that fixed it. So basically declaring it. See, I tried to do that with the other linker, the Clang way of doing it, and it didn't like it. This WL thing. I tried to do it that way. Oh no. Right, it didn't show up. It still showed up. Okay, maybe not. This doesn't work. She's saying try win main. Nah, same thing still happens. I think this is booted by Visual Studio. Visual Studio launches this for some reason. I don't think it's anything to do with the linker args, because if you run the application outside of Visual Studio, it doesn't show up. The title of the console window is the fact that it's trying to run the game exe, game.exe. Right, it's trying to run the game. I think it's something to do, like, it's running this command here. It's also specified here as well, output. It's weird. Yeah, I think it's something to do with Visual Studio, like some settings somewhere maybe. I could have swore I've turned it off before in the past, but it might be in a different type of project. So I'm really not sure. Something's fishy going on with this. Oh, it's made another bookmark. Why did someone like Ford declare any of this? Weird. Right, because this isn't hard to read. Oh, hot examples. Oh boy. Oh boy. Yeah, it's called Windows for a reason. Gives you Windows. What else do you expect? Uh. This with this guy. Dev info. So they zero the buffer. And then they set the size. Do we zero the buffer? Oh, love that spacing. Right, so zero the buffer. And then it sets this CB data size 1,000 for some reason. No, that's dumb. Ignore that because it gets set here. Right. I doubt that's going to change anything, but anyway, let's run that. Right, so it runs it right away. So I don't need to unplug or plug anything back in. So this is good, at least. Puts 32 in there. When we run this, oh, we get 32 back. So we did have to zero the structure for some reason. Weird. But anyways, this is going to run now. This is follow through since we're in the debugger. Runs here. This gets us the name, hopefully. Yeah, it got us a really weird name. But anyway, Um. Oh, that was a mouse. But anyway, we're gonna skip. We'll we only really want to do this get name, providing that you're in here anyway. So let's put a breakpoint in here and see what we get. Right. So let's plug another mouse in. I don't know if it really reaches. Weird. Right, that didn't plug in. So maybe it's because it's a union. Maybe hid is always set, you know? So because it's a union, maybe D word, D word, D word. Nah, it's completely different. As I said before, what is happening is you're launching through the script, which itself has console window, but you can detect the parent console that your app was launched. Right, so you can detect the parent console. Right, then you can free that. Hmm. Yeah, maybe that's the solution in it. Yeah, because they did say it, didn't they? It went too far up, it was here. No, it's a different one, wasn't it? Is that what you did you post it before Rust compiler? I think you did it, right? Yeah, you posted it. Parent process. And free it. But yeah, it's weird. Hmm. I don't know. Alright, so that managed to set fine. So the problem is now we're not getting this DW type is not hid, it's mouse. And I thought we could get it to be a mouse. Um, generic. There's keyboard. Is there a mouse? Or pointer maybe? Hmm. Yeah, I'm not sure why zeroing it mattered. It's very strange. It could have just been some other thing it was looking at. So this sets up the fact that the callback. Right. So what dev notify. So we kind of want to say. We kind of want to say. We want mouse events. Or is there like a hid mouse, maybe? Like a special one? Right, search for mouse. There's only one type of mouse. Hmm. So I don't think it's anything to do with that. Well, it could be. Let's have a look at the docs. An array of this guy. Yeah, we probably want this input sync one so we can receive events, the input when the window is not in the foreground or something. Yeah, I can't be able to create a new project maybe. But yeah, it's cool for now. Not support until Windows Vista. Oh no. Oh no. Anyway. So the event that we want is this one. We want that one. Type of raw input hid. We want that for the mouse and keyboard. Is that possible? So someone's done this get device thing. They've got a keyboard. Wait, okay, let's have a look at this. That's a 2. How's it got a 7? Good. Right, so maybe keyboard and mouse can't be hid, but then like... Oh... Because the main reason why I'm doing this is so I can get those vendor IDs. Basically, those vendor and product IDs, you know? But maybe it's not possible. Raw input, mouse, vendor ID. See if that's possible. That's all we want to get. Wait. Get device list. Does that get device list? And maybe get it through the... Oh no, it doesn't show up, does it? Hmm. So maybe we should iterate over the device list and see what we get. But it's not... really useful. Raw input mouse. Ah, just a checkbox away. Just what we want. Generic USB controller. I don't know. Two USB keyboards and mice connected to the system. Um, applications to distinguish these devices. I can differentiate my devices with the product or vendor ID. So thought using raw input methods and functions, but it only returns, type keyboard or mouse. This is our problem, right? Which doesn't have the vendor product ID related. Okay, how do I find the ID? Is this what we want? Right. And no one's replied. Amazing. Amazing. I have been given the link to someone else's code before, actually. I can maybe look for Joe Mega's code, I think. Because he's done this. but I think I lost the link. Well, it's on my other OS install, isn't it? It's not my Windows machine where it showed me the link before. So I won't be able to find it, I don't think. But yeah, I think he might have the code for this because he does this HID stuff. We want to get the HID sort of vendor IDs and that for, but maybe I need it for the gamepads. Yeah, someone will answer eventually. Yeah, maybe in before 2038, before the internet dies. You know, hopefully. Hopefully. See, they're not getting any other data. Do 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 do. Where are we gonna get this from? You just get an ID. I don't want an ID. I want like a. It's got to fit in with the abstraction, you know? We've got a vendor ID, product ID. How do we get those things? Oh, what a lovely language. What is this? DLL call. Oh, lovely. Uh, yeah, the vendor IDs there. Man, what a language. I have no idea what that was. Um, you must be able to get it. So, it comes in here and it's obviously not here. That mouse input. So maybe we can check on the Windows website. Like you get some form of mouse ID. Uh, I'm wondering like if you look for this structure, see this ID. A bit field of the mouse device identification properties. What does the game look like right now? It's got 3 compute shaders running using Vulkan, and it's just test stuff. We're just getting the core engine part together before we do some prototyping. There's a bit field with some properties, and it gets. So if it's got that one, it's a mouse. So you don't uniquely identify the mouse itself, it just tells you what properties it has. So it's not even really an identifier. Ooh, it's even worse. Yeah, so one way to uniquely identify a mouse. You have the device handle. But I want those vendor IDs and device IDs, you know. Yeah, ask GPT. Yeah, I'd have to log in and figure that out. Hmm. Hmm. Here's that part there. Hid attributes. Oh yes. Look at that. Hid attributes. Have a look at it. This looks like it's got something. How do we get hold of this guy? The attributes. There's a handle. This looks like it. This could be it. So what we might need to be able to do is say, well, if you are a case rim type mouse, so we'll put a breakpoint in there and try that out, right? So device handle. Ooh, address of a TTR. Bear in mind we dropped the P off the beginning there. And let's try that out. That might be it, right? That'd be amazing if so. Right, let's try that out. Oh no. I've got a link against something new now. Id. So the link args need might need something like that. There we go. 000. Isn't that great? So we might have to set the size, you see. So before we call that, I think it's returning false. So what it wants you to do is set that size, I reckon. So I think it wants you to say ATTR. Right, something like that. Let's try that. Oh, I didn't semicolon. And what do we get? Still 0. So I didn't really check the return type. I was trying to be a bit lazy, but so Boolean. Try that again. Is 0. So it's still false. So maybe you have to. Do you have to maybe like initialize the system or something like that? Well, hit device handle is right. I think it's this though. But maybe it's not. That's raw input maybe. So how do you get a hid device handle? Maybe. Oh, we might have to go a little bit more low level. USB device path. We must go a little bit more low level. See, I think in Nordillo's code, he does do something like this for the gamepad. I think he does something like this for the gamepad. Read file maybe. No. Wait, what other files did he have? They did like a read file, I think. Nah. Oh, okay. No, it's in the get raw. He's doing raw input still, and not using the hid stuff. So can we maybe turn a raw input handle to hid? Um. Yeah, there's nothing really here we can use. Because there's our handle, but I think it's raw input. Which might be different. Hmm. Um, I remember seeing there was some gamepad code in on GitHub. Um, remember seeing there was some examples. Yeah, this is a joystick maybe. Yeah, so maybe we can have a look through this one. But yeah, this is good. This is just gonna be for gamepad though, and maybe it's which will have the hid device already. So they've got raw input. Um, so they're just reading the input itself. Their L param is going to be obviously the handle to the device. Um, right, that's not going to help us at all. What about right? What about another one? Yeah, they don't really have any hid. Hid P. Is there a hid P something? That's hid D. Yeah, I wonder if we can get access to this object in some way. Or maybe you might be able to use Win32 hid. Yeah, perhaps we can use. Perhaps we can receive some different events, maybe, and go a level lower. Hmm. Right, so this is hid SDI EI. Public interface for parsing library. So hid P. Is there anything like event? Nothing like event in there. And nothing with the word event in here. Bear in mind. Okay. Cool. Um, Maybe we can see what the SDL source code does and see if they use anything. If we can't find it, we'll check the. See, we're doing this device thing already, right? This is WM input device changed. There's WM device changed. This one is to do with. Is this direct input or is this anything lower? Hmm. This might be something different. Um. A Win API application uses process to detect USB hid device unplugged. I just know the V and the PID. Don't have any handles. Right, so he's got this already. And the L param refers to documentation for each event. So what about arrival? And arrival says the L param device type then reserved. Ugh. I'm not sure if this is what we're looking for. Hmm. Right, I think I might do some research offline and see what I discover. I think I'll just start talking to people and see what they've done. maybe do some more research offline. Right. I think I'll put a pin in it there today. So okay, the next time we'll be on Thursday. So yeah, 6:30 p.m. GMT +1. Yeah, post in the Discord and update on what's going on. But anyways, right, let's find somebody to read. Right, it's someone streaming. Let's go. Right, thanks for coming, everyone. Yeah, so at least we got the OS interface, all the stubs in. We're just trying to figure out how do we plug the devices in and get some events working. So we kind of are getting there, but it's yeah, typical. It's just something slightly going wrong. But yeah, it's only more of a rabbit hole than I have to expect. Just to find a vendor ID. Exactly. Yeah, it's one of those. Yeah, it's just bizarre. It's like they're giving you too much of a high level thing. Yeah. But anyways, thanks for everyone's help today. It's really cool. But yeah, I'll do some research so we should stump this problem out pretty early next stream and then move on to something like actual keyboard input. Maybe mouse or keyboard input, you know. But anyways, yeah. Have a good rest of your week. I'll see you on Thursday. Catch you soon.